I'd like to introduce tonight's special guest. Our guest tonight is George Ellis, and if you've been involved with Texas Star Party or at the Texas Star Party, you've certainly heard George's name. George is a recently retired project manager and software developer for the defense industry. Along with Dave Clark and Don Garland, George was a principal organizer of the Texas Star Party from 1982 when TSP migrated to the Prude Ranch to 1986. George served as an Astronomical League president from 1984 to 1986 when the league hosted its first and largest international tour, taking 240 people to Peru to view Halley's Comet. George has remained affiliated with the Texas Star Party over the decades and currently serves as TSP's board chair and youth outreach coordinator. George lives in McKinney, Texas, with his wife, Anna Maria, with whom he hosted 2 expeditions to South America in the 1990s to view total eclipses in Peru and Venezuela. George has 4 grown children, all of whom have attended 1 or more total eclipses with their dad over the years. And as you can guess by the introduction, George is going to be talking about eclipses. So his talk tonight is called Total Eclipse Texas, a once-in-a-lifetime event. So George, I'd like to pass the microphone over to you.
Okay, I think we're ready to go here. Can you all hear me okay?
We can. We're seeing your screen.
Okay, I'm unfortunately I practiced this talk so much I've gotten a little bit of a hoarse voice, which was poor planning on my part.
No worries.
But let's go with the flow.
And George, we just see, there it goes. Okay, I was going to say we don't see the presentation, but it's there now. And what I was going to tell people is if you have questions for George through the chat, throughout his talk, I should say, use the chat feature that we have within Zoom, ask your questions there, and we'll get those answered in the order that they're received.
Thanks, Joe. It's really very much an honor for me to be here tonight to talk to HAS about one of my favorite subjects, astronomical or otherwise. I consider myself an eclipse chaser at heart, and that's maybe evidenced by my email address. I do want to acknowledge my longtime friend, Steve and Amelia Goldberg, who I've known for probably 40 years, along with Don Selly, who invited me to give this talk to you all tonight. I can only hope that I'm able to encourage everyone on this call to do whatever you can do to get into the path of totality next April, and hopefully with clear skies. Since Joe read my bio, I really won't rehash that except to say that my wife, Ana Maria, is pictured next to me. She's from Peru, and she shared my passion with eclipses over the years, co-hosting 2 eclipse expeditions with me. And she claims her rightful place as an eclipse chaser by having observed 5 total eclipses of her own, including 2 annulars. She saw her first eclipse before I did, actually, as she witnessed the total eclipse in southern Peru in 1966. For the benefit of any novice amateurs who may be in the audience, I'll touch briefly on what a solar eclipse is. A solar eclipse happens when the moon passes directly between the Earth and the sun, casting a shadow toward the Earth's surface. Whether that shadow reaches the Earth or not is basically the difference between a total eclipse and an annular one, which I'll talk about further in a few minutes. People want to know why there aren't solar eclipses every month. Well, for one thing, the moon's orbit around the Earth is elliptical, and because it tilts at about a 5-degree angle relative to the ecliptic plane, its shadow usually misses the Earth. Also, because the Earth itself has a 23.5-degree tilt, when an alignment does occur between the sun, the moon, and the Earth, the lunar shadow always casts a different path on or above the Earth's surface. Of course, that lunar shadow actually has to reach the Earth in order for an eclipse to be seen as total. But what happens if the lunar shadow doesn't reach the Earth? That's when you have an annular eclipse. An annular eclipse is the most obvious evidence that the moon's orbital plane around the Earth is a slight ellipse. If the new moon is close to perigee, its closest point to the Earth, while it's crossing the ecliptic, then it causes a total solar eclipse. However, if the new moon is close to apogee, its farthest point from the Earth, the moon will appear smaller in the sky than usual, so it can't cover the sun's disk. And this results in an annular eclipse during which a ring of sunlight is visible around the moon for a few minutes. There is one exception to this. According to Earth's sky, an annular eclipse can also occur when the Earth is at perihelion, the closest point to the sun that it gets during its own elliptical orbit. Which brings us to the recent October 14th annular eclipse. Thankfully, this eclipse occurred on a Saturday, which meant that many people who otherwise would have been at work, including my daughter Natalia, who teaches first grade in Austin, were free to enjoy the spectacle. To the right is a photo taken by my friend Will Young at the El Dorado Star Party. Will also posted a video of that eclipse, which I'll share with you now. Sometimes an annular eclipse may be in progress at sunrise or sunset. Here is a photo of a phenomenon called devil horns, which was taken just south of Lubbock back in 2012 when that eclipse was in progress at sunset. But back on the subject of total eclipses, here is a diagram that illustrates not only the umbra, but also the penumbra, which casts a wider shadow over the Earth. Everyone observing from within the penumbral zone sees a partial solar eclipse. The great astrophysicist and eclipse chaser Donald Menzel once wrote an article in National Geographic about the total solar eclipse that happened across Mexico in 1970. It was this article that brought to my attention the incredibly lucky coincidence of total solar eclipses. Namely, that while the moon's diameter is 1/400th that of the sun, its distance from the Earth is also 1/400th as far away as the sun. As a result, the moon and the sun generally happen to occur to occupy the same angular diameter in the sky. If not for this lucky coincidence, total solar eclipses would not be the spectacular visual treat they are for us here on Earth. My safety message, of course, you'll be hearing over the next 6 months the importance of having your eclipse glasses ready for April 8th. Just as my kids, Natalia and Chris on the left and Anjali on the right, had their eclipse glasses ready for the 2017 eclipse, so you will want to do the same. Order them early and from a trusted supplier of ISO certified eclipse glasses, such as eclipse2024.org. Be sure to wear them anytime you're looking at the sun prior to or after totality. And of course, use them only for brief glimpses of the sun. Do not stare for a long, prolonged length of time, even with the eclipse glasses. So what happens as totality occurs, or as it approaches? If you're standing within that impending shadow of the moon, you'll notice that it gradually becomes dark as the shadow begins to race over you. The temperature naturally drops and the wind dies down. You'll see the natural order of the world slide into chaos as birds quickly fly into the trees thinking nighttime is arriving. Crickets begin to chirp, and farm animals may make haste returning to the barn. The whole experience brings about an eerie, calm feeling. And if you're lucky enough to be watching the eclipse in the company of other people, you can expect spontaneous cheering will erupt. This is, to me, one of the neatest things about experiencing a solar eclipse. sharing the sighting with dozens, hundreds, or even thousands of other people. What other phenomena might you observe at the onset of totality? You might see shadow bands race across the ground if you happen to be looking at the ground, which most people aren't doing. You will see Bailey's beads and the diamond ring effect, which I'll show on upcoming slides. And you may very well see the pink chromosphere on the limb as totality begins. The shadow of the moon will envelop you as darkness rushes in. The stars and planets will appear in the newfound darkness. And best of all, the sun's corona appears in all its glory at a brightness roughly comparable to the full moon. If you're lucky, you might even be able to see bright pink prominences extending outward on the solar limb. Shadow bands are thin, wavy lines of alternating light and dark that can be seen moving and undulating in parallel on plain-colored surfaces immediately before and after totality. They arise because of turbulence in the Earth's atmosphere. In the final seconds before totality, refraction of the thin crescent of the sun through our atmosphere creates these bands, and the motion of the air makes them ripple and move. As the atmosphere is constantly changing, shadow bands are both short-lived and impossible to predict. Of course, most eclipse observers are understandably looking up, focused on the approach of totality, and do not notice the approach of shadow bands. The best way to capture this phenomenon is to place a white sheet or tarp on the ground and have a video camera running to capture the shadow bands as they occur. Bailey's beads appear as the last slivers of direct sunlight shine through the valleys and low areas on the limb of the moon just before totality. They also appear on the opposite limb of the moon just as totality is ending. It's also worth noting that Bailey's beads were named after Francis Bailey, who observed them during an annular eclipse in 1835 and described what he saw and explained their cause in 1836. The diamond ring effect occurs as a last ray of sunlight traversing the lunar limb and appears as a diamond set against the bright coronal ring around the moon. The diamond ring is one of the most spectacular moments during a total eclipse and occurs immediately before and after totality. And unlike Bailey's beads, a diamond ring does not appear during an annular eclipse, but only during a total eclipse. These two photos of the 2017 diamond ring illustrate how it appears just a few seconds apart. The first was by Steve Goldberg, and the second by my son, Louis. As the diamond ring ends and the beginning of totality occurs, this is the time you're able to enjoy the solar eclipse in all its glory without eclipse glasses or a filter of any kind. You'll have the opportunity to see the bright pink prominences and chromosphere on the leading edge of the limb. The chromosphere is a plasma layer that extends from 1,200 to 1,800 miles above the sun's visible surface or photosphere. You may also have the opportunity to see one or more prominences extending outward from the limb. Prominences are jets of plasma that can extend hundreds of thousands of miles above the sun's surface. While prominences can be seen anywhere with a solar telescope equipped with a hydrogen alpha filter, it is only during a total solar eclipse that you can see these amazing features without a filter. And they are spectacular, being considerably brighter than the corona itself. Lastly, of course, the corona is the most magnificent part of any total solar eclipse. It is the outermost part of the sun's atmosphere, generally extending as far as 8 million miles away from the sun. But the corona is believed to be 10 million times less dense than the sun's surface, so it is far less bright and thus can only be seen by professional astronomers with a coronagraph or by the rest of us during a total solar eclipse. This particular photo was taken by my son Louis at the 2017 eclipse with a 300 millimeter telephoto lens. So we've talked about the phenomena associated with seeing solar eclipses, but what's it actually like to see one? I went through several eclipses without bothering to take a video of the surrounding environment. But I had my son Chris with me during the total solar eclipse in Queensland, Australia in 2012. And he took a video with his phone as we were observing on the beach, along with a couple of hundred other people. And the public reaction to seeing this eclipse was truly profound. Let's take a look.
Oh my God.
Let's see. Let me try to get this shut down here. My Zoom is kind of in the way. There we go. Okay. There. Who are eclipse chasers and why do we do it? Kate Russo is an eclipse chaser and a clinical psychologist who has written 3 books about the psychology of eclipse chasing, including Total Addiction, The Life of an Eclipse Chaser. The 2012 edition of her book estimated between 200 and 500 chasers worldwide, although I personally think this number is extremely low. She identifies the average chaser as male and about 46 years old. 39% of chasers are from the US, and the average number of eclipses seen by chasers is about 7. Why do we do it? There's clearly the opportunity to repeatedly experience the range of strong emotions that seeing an eclipse evokes. There's also certainly the challenge to go anywhere in the world to see or photograph one of nature's rarest spectacles. But for me, I just think it's the most amazing thing you'll ever see in your life. Nothing I've ever experienced compares to it. Who is the world's top eclipse chaser? It probably won't surprise most of you that he's Paul Maley, who lives right here in Houston. He's the world record holder, having traveled to observe 82 eclipses all over the planet. If you go to his website, you'll read about the many other astronomical phenomena, such as occultations and transits, that Paul has traveled great distances to see and photograph. My own eclipse chase is pale in comparison, but I've nonetheless traveled to 9 totals around the world, as well as 3 annulars, all right here in the US. My first was in Perry, Florida in 1970 when I was in middle school. And even though I got clouded out of that one, the experience of midday darkness was fascinating, and I was hooked on seeing more eclipses. And incidentally, I've been pretty lucky, having only been clouded out one additional time at an eclipse in Mexico in 1991. I have to share this eclipse story from the Sahara in late June 1973. That eclipse was a 7-minute total, the longest in nearly 1,000 years. I had the unique opportunity to join an expedition to Mauritania to see it, thanks to the wherewithal of my parents and the willingness of the expedition leader, Roger Tuthill, to allow a 15-year-old kid to participate in a potentially dangerous trip to the hottest place in the world in the middle of summer. Notably, this particular expedition was immortalized in an article in Rolling Stone magazine that ironically had perhaps one of the best eclipse articles ever written. Titled The Eclipse of the Century, this article covered the story from the angle of totality addiction and how could it be possible that so many people could rush into the Sahara Desert for 6 minutes of midday darkness in the middle of summer. Here's a quote from the opening article. Solar eclipses are as perverse a natural phenomenon as one could want. favoring in the main Arctic tundra, uncharted ocean, and sun-blasted desert for their approximately semi-annual appearances. Their perversity is matched, insane locale for insane locale, only by the perversity of the totality addicts. And so almost overnight, 4,000 people from at least 11 countries were clamoring to get into the drought-cursed desert with 15 tons of optical equipment to do a little starry-eyed camping. And from the fourth page of the article, totality addiction strikes without regard for age, sex, or occupation. The only common denominator connecting the members of the expedition is that virtually everyone has seen at least one eclipse. Most have seen 2 or 3, and one elderly couple claims 6 and 7, respectively. The article was full of humorous anecdotes, such as this one. 20 kilometers west of our compound is a camel watering hole frequented by tribes of nomadic goat herdsmen. A Japanese photographic team decides they will drive out in Land Rovers on the day of the eclipse to photograph the colorful and unfiltered primitive reaction. They arrive just as another Land Rover filled with Americans is departing, leaving behind a whole tribe of delighted nomads, each covering his face with a big shiny sheet of brand new space-age mylar to observe the eclipse. But the real reason I found this article in the first place is because a high school friend told me that I had my picture in Rolling Stone magazine. And sure enough, that's me in the montage of photos on page 40, completely oblivious to having had my picture taken at all, and even more oblivious to where it would end up. I'll share one more story with you. In 1991, my wife and I and our 2 oldest children went to Mexico to see a 6-minute eclipse. Having failed to rent a car due to unavailable supply, we had arranged for a taxi to take us north to the center line. However, the night before, the taxi companies colluded to raise cab fares tenfold, and we ended up hopping a bus full of tourists from the island of Martinique to get to the eclipse. We tried to set up our equipment at one location, but as the clouds rolled in, we had to hastily tear down our equipment and reboard the bus. In my haste, the wooden cradle that held my small equatorial mount split into 2 pieces, leaving me in a state of unbridled crisis. I did develop an ingenious fix to restore the cradle, but we were clouded out at the shoreline while the sky remained clear in the distance over the Gulf of California. I kept thinking, if only we had a boat. Now, I hope I'm among friends here because I'm about to confess something. My ingenious fix to repair my mount happened as the bus was creaking along down the highway, and I noticed that it was being held together by hundreds of machine screws. So I got my screwdriver out and took about 4 of those screws out of the bus to repair my cradle. The fix worked, but I couldn't help but wonder how long the bus was going to be held together with those 4 missing screws. Please don't tell anyone. From 1973 to 2017, I am still chasing that lunar shadow, here with my sons Louis and Chris in Rigby, Idaho, along with my 3.5-inch Questar. And yes, if you look carefully, that is a filled Gatorade bottle I was using to balance my camera on the Questar, since the counterweight somehow didn't make it into my Eclipse gear for Idaho. The screws on the bus weren't my only Eclipse hack, but I have to give credit for this idea to my sons. I'm still learning how to do this after all these decades. My longtime friend Ann Atkins from San Antonio went to Broome, Australia earlier this year to witness the rare hybrid solar eclipse on April 20th. She arrived a week early, but unfortunately so did Cyclone Ilsa, a Category 5 storm which made landfall just south of Broome shortly after Ann arrived. Ann also reported having experienced a magnitude 4.0 earthquake in the days prior to the eclipse. According to Ann, my Aussie friends were sending me dire warnings days before, telling me there was potentially a massive cyclone headed my way. But what was I going to do? I wasn't going to miss totality. Spoken like a true eclipse chaser. and also went to Mount Imei, if I'm pronouncing it right, in China to see the long total eclipse in 2009. She was told it never rains on that mountain. Famous last words. It rained on top of the mountain on eclipse day. And to make matters worse, afterwards she encountered tourists who had seen the eclipse on a Viking river cruise, where they were just stepping out onto the deck of their ship to take in some sun, and instead witnessed the sun turning into a black ball. Moral of this story, life just isn't fair sometimes. My HAS friend Steve and Amelia Goldberg had heard Fred Espenak speak at TSP 2017 about the upcoming eclipse, and he recommended Madras, Oregon as the best place in the US to see it. Well, sometime later, Steve and Amelia had encountered another couple in a hospitality room while waiting to board a cruise, and learned that that couple was from Madras, Oregon. Lo and behold, they became friends, and Steve and Amelia ended up having an invitation to Madras to see the eclipse from their new friend's home. And I think all of this started by a chance encounter in Juneau, Alaska. What were the odds? Okay, so back to the present. What about this upcoming eclipse on April 8th next year? I want to kick off the next section of this talk with an acknowledgement of Dan McGlown, author of the very popular website eclipse2024.org, a website which I urge all of you to visit and learn about the eclipse and about the amazing capabilities of this website. This amazing interactive website has custom links to every department, state, or province in the path of totality in Mexico, the US, and Canada. If we take a look at what the site shows us for Texas, the website outlines every single county in Texas and shows which counties are within the path of totality. A description underneath denotes which cities are in or not in the path. I am highlighting what the description says about Houston, which will see a 94% eclipse. But the real useful feature of eclipse2024.org is its eclipse simulator, which enables the user to view a simulation of the progression of the eclipse from any location in or out of the path of totality. Let's take a look at this capability. The eclipse simulator begins with a map showing the path of totality. The user can perform a city search or interact directly with the map. To begin, let's zoom in on Texas. From this magnified view, we'll click on a particular location on the map, and a pop-up will appear showing the latitude and longitude of the location you've selected, whether the eclipse is total or partial from that location, the nearest town in the eclipse2024.org database to the location selected, and a link enabling you to view a simulation of the eclipse from that town. Once you've started the eclipse simulator, you'll see a depiction of the sun where it will appear in the sky prior to the start of the eclipse. There are numerous features of this eclipse simulator, including a time slider to magnify the solar eclipse on the simulation. The time slider manually expedites the eclipse and includes a right arrow to run or pause the simulation, a zoom to magnify the image on the simulation, check boxes to view specific eclipse phenomena or to turn the sun's glare on or off, and a pop-up window that appears at the upper right to view progress of the shadow approaching the simulation location as the total phase of the eclipse nears. Let's take a look at a simulation of the eclipse from a place called Smith's Bend. So here's the sun. As you see, we can magnify it. And we can also move the time track forward to any point we want, including just before totality. And we'll stop at about 1:35. And then we will speed up to about 5 times normal speed, and we'll start the simulation. You see here, it shows you the time, it shows you the magnitude, and as the eclipse becomes closer to total, you'll see the shadow pop up, which shows you the shadow as it's approaching the location that we've identified. Let's magnify it even a little bit more. And let's turn on glare, why don't we? There you go. And we are in totality. The track shows the path moving across, the shadow moving across the path. And again, we are running this at about 5 times normal speed. I'll go ahead and pull it forward a little bit to accelerate this further. And then as the shadow reaches the point where we are observing from, we'll see totality come to an abrupt end. And there you have it. I might mention also that you have the additional opportunity to magnify the time element itself so that you can see very, very minute changes in the eclipse going forward. So there's opportunities to zero in on the second or third contact as you choose to do so. So that's basically an overview of the simulator. In case you're wondering why I chose Smith's Bend as a site to run the Eclipse simulator, it happens that Smith's Bend is the closest location to the Texas Star Party solar eclipse event. You knew this was coming, right? The TSP is going to host a special solar eclipse event at a centerline location, the Latham Springs Camp and Retreat Center near the town of Aquilla, Texas. Like all TSPs, the Eclipse event will feature guest speakers, on-site meals, a variety of accommodations, a vendor area, and a dedicated observing field. This particular TSP will be unique in that the event passes will be offered for various on-site packages encompassing an entire 5-day, 4-night stay from April 5th through April 9th. So there's no, I'm going to go just stay for one night. It's basically you're buying a pass that gets you 5 days and 4 nights at the facility. This will give the attendees an opportunity for both solar and nighttime observing throughout the weekend prior to the eclipse, and afterward, an extra night to spare them from braving post-eclipse traffic after totality ends. Here's a map to give you an idea where Latham Springs Camp and Retreat Center complex is located. It's roughly between Aquilla and Smith's Bend on the banks of the Brazos River, about 20 miles southwest of Hillsboro and 35 miles northwest of Waco. Totality will be 4 minutes, 23 and a half seconds from this location, immediately west of the center line. Latham Springs is a property encompassing about 400 acres, including all types of accommodations from bunkhouses and hotel units to RV slots and camping. The site has its own meeting hall, dining hall, climate-controlled facilities for vendors, and a remote field with good horizons for observing. And here are photographs of some of those facilities to give you an idea how they are. The hotel units, dining hall, observing field, and the auditorium. These are the speakers who have been lined up to give presentations at the TSP Eclipse event, including Bill Waddell from AccuWeather, Dan McGlone from eclipse2024.org, David Kipping, who studies satellites and planets beyond the solar system at Columbia University, Camille Carlisle, who is a science editor at Sky and Telescope, Ted Saker, a veteran eclipse chaser and master visual observer and an astro imager, and Rob Galucco, a landscape and nature photographer from Southern Arizona. I'm providing you the website and an email address if you have questions. But I want to say one more thing about the TSP and why we're doing an eclipse event. Beside from the obvious desirability of having a total eclipse of the sun occur during our event, we recognize that our annual pilgrimage to far west Texas has been difficult for many, many people to attend. People such as students, families, teachers, college professors, who many have never been able to witness and experience a TSP. We hope the uniquely convenient location of this event will introduce astronomy to many new people and hopefully introduce new people to TSP. So, why do you need to see the April 2024 eclipse? Before we tackle this question, let's take a look at how we know when and where eclipses are going to occur. With this, I introduce to you the concept of Saros cycles. A Saros is a period of 18 years, 10, 11, or 12 days, depending on the number of leap years, plus 8 hours. This is the amount of time it takes for the sun, the earth, and the moon to return to the same relative geometry, a nearly straight line, for another eclipse to occur. The successor eclipse will have similar characteristics to its predecessor and will occur about 1/3 of the way around the world west of where its predecessor occurred. The Saros series encompasses all of the eclipses that occur as part of the same Saros cycle. So there are about 40 Saros series active at a given time. A Saros series lasts between 1226 and 1550 years. A Saros series begins and ends with a series of partial eclipses, and in between those, sequences of annular eclipses, hybrid eclipses, and or total eclipses will occur. So let's look at Saros 134. This was the Saros cycle of October's annular eclipse. For just this one, we'll run this entire Saros series from start to finish. It began in June 1248 and ends in August of 2510 for a span of 1262 years. As the series progresses, you'll note the following as the video moves. The type of eclipse, the date the eclipse occurs, where the center line is, if there is one, and the duration of that particular eclipse, if it's total or annular. And watch this carefully. It goes extremely fast, but it'll at least give you an idea in very quick terms what a Saros series looks like. There you go. Doesn't take long, does it, to span 1262 years. Slowing that down a little bit, we're going to look at a couple of paths just before and after the annular eclipse. Here's September 23rd, 1987. That annular eclipse crossed China and Western Pacific. It was followed in 2005, 18 years later, by another one with the same general orientation, this time a third of the way around the world in Africa. And then our October 14th, 2023 annular eclipse, same orientation, this one crossing the Western US, Central America, and Northern South America. And the next one after that, 2041, is going to occur across pretty much open ocean. The one after that, again, will occur in Africa. And the one after that, lo and behold, back in the US again, similar orientation as before. And we can look forward to another annular eclipse just like the one we just had in 2077. Can't wait. Now let's look at the Saros of next April's total eclipse. Again, we'll start back in March 1970, which happened to be the first eclipse I ever saw. This one crossed Mexico and the eastern seaboard. And as we go 18 years forward, again, it goes a third of the way around the world to the Western Pacific. and a third of the way around the world from there in 2006 to Africa. And here we are in 2024, April 8th, the eclipse crossing Mexico and the central US and the Northeast and maritime Canada. Again, going 18 years beyond that, we have another one in the Pacific, another 18 years, another one in Africa, and another 18 years. Look, we have another one in May of 2078. This one's going to just clip Texas and cross the southeastern US and go out into the open Atlantic. I'll do one more Saros for you, the longest eclipses in modern times. This was 136. Notice that this one, the eclipses were 6 and 7 minutes long. This was my Mauritania eclipse in June 1973 across Central Africa. Moving forward, we had the one in 1991 that crossed Mexico and Central America. 2009, the one that crossed China. Another one in 2027 that's going to cross Northern Africa. And lo and behold, in 2045, we'll have one that will cross the range of US from Canada all the way to Florida. It won't hit Texas directly. We'll have to drive to see that one. But put down August 12th, 2045 in your book. That's one you won't want to miss. Notice also it's 6 minutes and 6 seconds of totality. So what else do today's chasers have to look forward to after 2024? This map shows once you remove the paths for 2017 and 2024, there aren't a whole lot of good prospects for the US for the next 30 years or so. Within the US, the next total eclipse will occur in western and northern Alaska in March of 2033. 11 years later in 2044, a total will occur over western North Dakota and eastern Montana, as well as western Canada. And in 2045, the 6-minute total across the US that we just spoke about, that will cross California to Florida and into the Eastern Caribbean. Now, beyond that, what do we have to look forward to worldwide? Well, for 2030, for the eclipses through 2030, here's our April 8th one next year. We also have August 2026, which will cross Iceland and parts of Spain. This will give viewers in Reykjavik and Valencia an opportunity to see a total eclipse. And then August 2027, one will cross southernmost Spain, the Strait of Gibraltar, North Africa from Morocco to Egypt, with totality expected in Gibraltar, Tangier, and Luxor. Finally, July 2028, there's going to be one in Australia, which will go right over Sydney. Another 10 years out, 2031 to 2040. Well, here's the one across Alaska that we spoke of. And in addition to that, in March of 2034, another one will cross Africa, as well as Saudi Arabia, Iran, Afghanistan, Pakistan, and China. September 35, we'll have one that crosses China, the Koreas, and Japan. And 2037, we'll have another one across Australia. This one from north of Perth, across the outback through Uluru and Alice Springs to Brisbane, as well as the North Island of New Zealand. But we're not done. 2041 to 2050. 2042, we'll have one that crosses Malaysia, Indonesia, and the Philippines. August 2044, this is the one across Montana and Canada. August 2045, the one crosses the US. And 2046, we'll have one that crosses Angola, Botswana, and South Africa. Lastly, 2051 through 2060, for those of us who are still around. March 2052, we'll have one that crosses Mexico and the southeastern US. 2053, we'll have one that crosses the Strait of Gibraltar again, the coasts of North Africa, Egypt, Saudi Arabia, Yemen, the Maldives, and Malaysia. 2055, we'll have one which crosses South Africa. And 2059, we'll have one that crosses Ecuador and Brazil. And finally, 2060, we'll have one that crosses northwestern Africa from the Ivory Coast to Libya, Turkey, Azerbaijan, Turkmenistan, and, well, you get the idea. In any case, hopefully I've made my point that for the next 50 years or so, I think we can safely say that April 8th, 2024 can truly be considered a once-in-a-lifetime event for Texas, and that you all need to be a part of it. Thank you for your attention. I'm open for questions.
Appreciate that, George. Thank you so much. That was absolutely wonderful. And as Bill Spitzeri said, I echo this. He said the pattern is absolutely hypnotic for those Saros cycles. So that's absolutely amazing. All right, so we'll go ahead and open it up here for any questions you may have for George. If you have a question, come off of mute and ask directly of George. While we're waiting there, George, I will ask you, as an eclipse chaser, which eclipse that you've observed has been your favorite?
Well, for different reasons, I suppose. I got my best photographs in 2017. Those were some of the ones that I showed in the slide presentation. I had an opportunity to use a Questar that didn't belong to me in my youth, and I took it to a couple of eclipses and dedicated the next 30 years or so of my life to acquiring one of my own, which I finally did and used for 2017. The other great ones from a standpoint of brilliant skies were 1998 in Maracaibo, Venezuela, which was spectacularly clear. And the most surprising ones were 72 in Cap-Chat, Quebec, when the sky cleared during totality. That was the first one I ever actually saw. 1973 for the duration of totality. I mean, everyone is special in its own way.
Perfect. Okay, thank you. Okay, does anybody have any questions for George? Okay, going once.
You all do have my email address, the eclipsechaser@gmail.com. Feel free to write to me if you think of something later you want to ask.
Sounds good. And I thought I heard somebody chime in there. Just
a question here. This
Yes.
is Patrick Woody. Is there any, does it make sense to, along the path of totality, to look for a location that would have the lowest chance of rainfall based on historical weather? Or is that just a bit of is it too much work for too little payoff?
That depends on how big a chaser you are, right? I think I'll give you an example. 1991, everybody who, and I think this included most of the chasers who were far more skilled than I was, went to Baja California, to the southern tip down around Los Cabos, and saw totality where I waited too long, went to Puerto Vallarta and tried to see it from the mainland side of Mexico, and I got screwed. So, yes, absolutely. If the powers that be, including people like Fred Espenak and Jay Anderson, recommend one area over another, a lot of the chasers, that's where they're going to go. Certainly within the U.S., Texas has the best weather prospects of, I think, anywhere in the North American path. But, last year we got 4 straight days of socked-in cloudiness around eclipse time. So I think we're due for a better year this year.
Okay, thank you.
Okay, thank you. And for those of you who have not made plans or accommodations for the upcoming eclipse, it's getting really tough to find a place either through Airbnb or anything else like that in Texas. So, if you haven't done that yet, Texas Star Party does have room still available, and that may be an option for you if you haven't found a place yet. Okay. Any other questions for? Yeah, of course. Any other questions for George? All right. Well, George, thank you again. This is a wonderful presentation. Certainly timely given the annular eclipse that just passed and the upcoming total eclipse. As you mentioned, if you've never seen a total eclipse in the path of totality, if you're going to be at 98% coverage totality, you may as well be at 2%. I've always said that. That may be exaggerating a little bit, but when I observed the total eclipse in Jackson, Wyoming back in 2017, like you said, there's this eerie stillness that precedes the eclipse itself. We started to hear wolves howling and birds doing strange things. Animals were doing all kinds of strange things prior to the eclipse. And then once you hit totality, it really is like nothing you experience. A lot of emotions, a lot of people crying, a lot of people experiencing other types of emotions as well. And it really is something that is incredible to observe. And even I would say more important for me, at least, was to observe with a group of people, right? Just to experience it with others as well, as opposed to by ourselves. I did see somebody had a hand up. I don't know if they moved their hand down, but was there another question?
That was me. I was just going to say that in 2017, there was a big group of young women. They looked like they were college age, and they were just partying and everything like that. And the totality happened, and first they started giggling and then they started crying.
Yes.
So all kinds of emotion.
Absolutely. And you have to be in the path of totality to really experience it. So,
and don't let anybody tell you that you'll see the pictures later and you'll see it on the internet. That's the same thing.
No, you have to be there for these
Absolutely.
things. Absolutely. All right, George, thank you again for the wonderful talk. This is, like I said, really informational, inspirational. Hoping everybody who doesn't have plans for the next year's eclipse is able to get those taken care of soon. And for those of you that do have plans, wishing everybody clear skies and a great opportunity to observe. So thanks again, George.